to catch them is my real test. 8.4 Intro to Trigonometry. We are going to start to do some trigonometry, which is kind of a big deal because trigonometry is a pretty upper level class, but we're just getting a little introduction to it. And the reason is because trigonometry, if you look at the prefix trig or tri for triangle, that's a shape that we've been studying in geometry, so now we're going to focus on even more rules for triangles. So let's see how that goes. All right, let's take a look at this triangle. It's a right triangle. Today we're going to only deal with right triangles. We have some sides, side A, side B, side C, and then I have an R. That's going to stand for an angle. I want you to look at angle R, here it is, and ask yourself, how does angle R relate to side A? Do you think it is opposite or adjacent or the hypotenuse? The answer is, it is the opposite. So side A is directly opposite of angle R. Let's do that for side B. How does angle R relate to side B? It is adjacent. Now adjacent means right next to, but then isn't C also right next to angle R? It turns out because side C is the hypotenuse, then it gets the hypotenuse name, and then B gets the adjacent, the one next to. All right, so know the difference between the word opposite, the word adjacent, and the word hypotenuse. Boom! What the heck is this? SOHCAHTOA. Sounds like a weird word, but it is actually an acronym. It's a geometric acronym to make ratios. All right, the S stands for sine, and then the O stands for opposite, and the H stands for hypotenuse. The C stands for cosine, and then the A stands for adjacent, and the H stands for hypotenuse. And then lastly, T stands for tangent, O stands for opposite, and H stands for adjacent. All right, so the S, the C, and the T, sine, cosine, and tangent. If you look on your calculators for those buttons, they should be abbreviated SIN, COS, and TAN. Sin, cos, and tan. But it's actually standing for sine, cosine, and tangent. All right, let's see how this acronym helps with our studies in trigonometry. All right, here's a triangle. It's kind of the same triangle I drew earlier, except it has some numbers in it. 15, 20, and 25. The homework is going to ask you to find the 3 trigonometric functions for this triangle. All right, so what they want you to do is find sine of x, cosine of x, and tangent of x. So those are the 3 things they want you to find. All right, so the first thing we're going to do is sine of x. Now what does sine mean? I wrote it up here. It means the opposite side over the hypotenuse side. So if you look at x, what's the opposite of x? The 20. And what's the hypotenuse of x? The 25. So sine of x is equal to 20 over 25. Reduce your answer, 4 over 5. Let's do cosine of x. So here's x. Cosine of x is adjacent, which is the 15, and the hypotenuse, which is 25. So 15 over 25 reduces down to 3 over 5. And to do tangent, we need opposite over adjacent. Here's the opposite side. Here's the adjacent side. 20 over 15 reduces down to 4 over 3. All right. So those are the three trig functions for x. Guess what? Now you have to do the three trig functions for z. So now we have to move our focus over here to the z. We first have to find sine of z, which is opposite over hypotenuse. This is the opposite of z, and this is the hypotenuse of z. 15 over 25, reduce it. And then we have to do it for cosine, adjacent over hypotenuse. Which is 20 over 25, reduce it. And then tangent of z. Tangent of z. Tangent is opposite over adjacent. So here's z, here's opposite, here's adjacent, 15 over 20. All right, so those are the three trig functions for x and z. Guess what? You do not have to do it for the y. You don't do it for the angle that is 90 degrees, only for the other two. All right? All right, let's look at your calculator. So you were asked to get a scientific calculator to work with. If you don't have a calculator, you can actually use your cell phone, but then you have to, I think if you have an iPhone, you have to turn your cell phone sideways. But it's better to have a calculator because there are the three buttons. I don't know if you guys can see, but right in the middle, it says sine, cosine, and tangent. It's a sin, cos, and tan, which stands for sine, cosine, and tangent. All right, so make sure your calculator has those buttons. But before we use them, we actually need your calculator to be set in the right mode. All right, it has to be in the degrees mode. And the way you set the degrees mode is, and all the calculators are slightly different, but if you look right here in the tiny screen, that actually says RAD, which stands for radians. We are not going to work with radians. We actually want it to say DEG, DEG, and that stands for degrees. So don't have it in rad. We want it in degrees. All right, and so the way most of the calculators will come set for using degrees, which is nice. It might say DEG or just has the letter D in it. And this one has the letter R in it. All right, if you need to change it, the button to change it is right here. If you notice, there's a DRG, and that changes from degrees to radians to gradians. And so we are going to want the calculator to be in degrees. Let's go ahead and see if your calculator is in the right mode. Let's punch in some numbers to see. Go ahead and punch in sine of 25. Some calculators you have to push the 25 and then the sine button. Some calculators you put the sine button first and then the 25. So depending on how your calculator works, test it out. You should get 0.4226. It actually goes on forever. 0.4226, but I'm just going to round to 4 decimal places. Let's test out for tangent. Put in tangent of 72. Hopefully you get 3.0777, and then there's a whole bunch of other numbers, but 4 decimal places, all right? If you got those two answers, that means your calculator is in the right mode. If you didn't, then you have to reset your calculator so that it is in degrees mode. All right, moving on. Find the sides. How are we going to use SOHCAHTOA to find sides of a triangle? So up until now, we've done the Pythagorean theorem. A squared plus B squared equals C squared. And so you do that stuff and you solve it out. But sometimes they don't give you enough information. This one has a c squared. They're asking for one side, but then the other side's missing, so you can't use Pythagorean theorem. And so then we use trigonometry, SOHCAHTOA. Let's use it. All right. First thing we do, we want to look at the degree that's given, this 23 degrees. Always look at that degree, write it down, and then you're going to ask yourself, how does that degree relate to the x? It's opposite. How does that degree relate to the 72? It is the hypotenuse. So, looking at our acronym, SOHCAHTOA, which one deals with opposite and hypotenuse? An O and an H. If we look, this is the only one that has OH in it. So we're going to use the sign button. All right, hopefully that wasn't too confusing, but we will definitely do a whole bunch of examples more. All right, so there it is, the setup, sine of 23. To complete the setup, you have to write in the O and the H part, equals x over 72. All right, that is the setup to solve for x. The next part you have to do, go ahead and punch in your calculator sine of 23. Sine of 23 is approximately 0.3907. And then this just becomes a regular equation to solve. Multiply both sides by 72. Final answer, 28.1326. I'm going to round to 4 decimal places. All right, so we've solved for x using trigonometry. How fun! Let's continue. Let's do another example. Here we have the x's down here. We have to solve for x. First thing you do, look at the degree, 72. Write it down, and then you have to ask yourself, how does that 72 relate to the 22? It is the opposite. How does it relate to this x right here? It is adjacent. So we have to look for the one that has the O and the A, opposite, adjacent. Right here, opposite, adjacent, that's the only one that has the O and the A. Which means we're going to use tangent in the problem. So tangent of 72, and then finish the setup. What is it equal to? Opposite over adjacent, OA. All right, on your calculator, punch in tangent of 72. You should get that decimal. Now, this is an algebra problem where you have to solve, but the x is on the bottom. How do you do that? Multiply both sides by x, and then divide by the decimal. X is approximately 7.1482. All right. That is how you solve for the missing sides when you cannot use Pythagorean theorem. Sometimes they ask you to solve for more than one thing. So in this case, this one has an x and a y. But you do it the same way. You solve one letter at a time. Let's focus on the x first. We'll solve for x. First thing you do, write down the degrees, the 28. How does the 28 relate to the x and the 15? It is opposite and adjacent. Opposite and adjacent means, oh, you're going to use tangent button. So tangent. Finish the setup. There's the opposite, there's the adjacent. Punch 28 or tangent of 28 into your calculator, and then to solve for x, multiply both sides by 15. There's x. Now we're going to do the same thing with y. This time, you have to ask yourself, Still starting with the angle 28, you have to ask yourself, how does it relate to the y and the 15? Since we're not dealing with x, don't look at the x. So the y and the 15, we still have adjacent, but then the y is hypotenuse. Which one is AH, adjacent and hypotenuse? There it is, which means you're going to use cosine. Finish the setup, 15 over y. To solve for it, punch 28 cosine into your calculator, multiply that y over to the other side to get rid of the fraction, and then, oh no, it went out of order, but divide both sides by that and you should get this. Alright, so hopefully you start picking this up. This is a long section, so we're going to continue. What happens if the angles are missing? So they give you the sides, but now the angles are missing, because I told you, you always start with the angle, but now there are no angles, except for the 90 degrees, but we never use the 90 degrees. Alright, let's solve for the angle. And you're going to set it up the same way. First thing you do is look for the angle A. Usually that's the first thing we write down, so that doesn't change. We're going to write it, but instead of a number, we're just going to write angle A. Then you have to ask yourself, how does angle A relate to the 20 and the 15? That's opposite, that's adjacent. Opposite and adjacent again. Looks like we're going to use tangent. Complete the setup. You have tangent is equal to opposite, which is 20, and then adjacent, which is 15. On your calculator, go ahead and do 20 divided by 15. Turns out it's 1.33333. Now here comes the weird part. We're looking for A. We're trying to solve for A. How do we do that? How do we somehow get rid of this tangent? Any guesses? Look on your calculator. There's the tangent button, but we're not going to use the tangent button. The opposite of the tangent button, or the inverse of the tangent button, is actually right on top of it. It says tangent to the -1 power. That means tangent inverse. So the inverse actually does cancel out the tangent button. So what we do is we put tangent inverse on this side of the equation. That cancels the tangent. But remember, in algebra, whatever you do to one side, you have to do to the other side. So you also have to tangent inverse the other side. And when you push tangent inverse 1.33333, you get about 53 degrees. All right, let's try another one of those. I've moved the A. The A is now down here. We're going to try to solve for that, so we'll put angle A again. How does that relate to the 73 and the 100? It's adjacent and hypotenuse. Adjacent and hypotenuse, this is the only one that has an A and an H in it. So it looks like we're going to be dealing with cosine. Finish the setup. Cosine of A is equal to 73 over 100. Then your calculator, punch in 73 divided by 100. And then, how do we get rid of this cosine? Cosine inverse. Both sides to get 43 degrees. All right, we're almost done. We only got 2 more presents left. Solving the triangle. To solve the triangle, so the directions, if they say solve the triangle, if they want you to do that, you have to find all 3 angles and find all 3 sides. So basically a triangle has 3 angles and it has 3 sides. To solve it, you have to find them all. All right, let's go ahead and solve this triangle. You have to find all three angles and all three sides. But notice they already give you a lot of information. They give you the hypotenuse, they give you one angle, and they're always going to give you the 90 degrees. So they give you a lot of information. You just have to find everything else that isn't there. All right, let's go ahead and look for angle M first. Angle M is missing. Well, this one is actually very easy to do because if you remember the triangle sum theorem, we know that all three angles in a triangle must add up to 180. They already give you the 70, they give you the 90, you just have to solve for the third one. And it turns out to be 20. Those add up to 180. Oh, so we didn't even need to use trigonometry to solve that angle. And then you don't always have to. If you know two angles, you can find the third one using the triangle sum theorem. Sometimes there's a problem where they give you two sides. If they give you two sides, you can use the Pythagorean theorem. This is the stuff you already know. You only use trigonometry to solve for things you can't do using those you already know. So let's now go ahead and look for this side over here. I'm going to call it R, and there's a very specific reason why I'm calling it R, little r. In general, when we're labeling shapes, if the angle is capital R, then the side across from it will always be the lowercase r. So capital versus lowercase. It's to match it up nicely. And so you'll see that throughout my notes too. And it does kind of matter, so pay attention to that. Let's solve for r. Let's set it up. First thing we do, 70 degrees. How does it relate to the r and the 15? It is sine, opposite over hypotenuse. I wrote it up here just in case you forgot. So sine of 70 equals r over 15. That's the setup. Solve it out, punch sine into the calculator, and then multiply both sides by 15. We have r. Well, let's go ahead and find this side over here. And guess what? We're going to call it M. Just because it's directly across from this big M. All right. Let's go ahead and set it up. How does the 70 degrees relate to the M and the 15? It is cosine. It's adjacent over hypotenuse. Punch it into your calculator, multiply by 15. You have, oh, that's supposed to say M, not R. M is equal to 5.1303. All right, we have all the information. We have all three angles and all three sides. We have solved the triangle. Now, some of you guys might be asking, well, we know this was 20. Could we use 20 degrees instead of the 70 in all of these problems? You could have. You could have done 20 to solve for the R and solve for the M, and it would still work. But the general rule is always try to use what is already given to you. The 70 was already given to you, so use that one. All right? That was a very long lesson, probably the longest lesson we've had, but it's trigonometry. It's something new, and so I needed to show you a whole bunch of stuff. Go ahead, try it on the homework.